Assalamu alaikum wa rahmatullahi wa barakatuh. This is subject science, 10th class. Name of the unit is light. So, in this video, we are going to derive the relationship between focal length and and radius of curvature. We know that these terms, focal length and the radius of curvature, both are these distances, focal length as well as radius of curvature. Focal length is the distance between focus, principal focus, and the pole of the mirror, whereas the radius of curvature is the distance between center of curvature and the pole of the mirror. Like this, यहाँ मैं बनाऊंगा ठीक. Here, if this is concave mirror, this is part of this sphere, hollow sphere. ठीक. Center of this sphere is C. This is called the center of curvature, and this is the mirror, mm dash. ठीक. mm dash is the aperture of this mirror, and this is the focus, capital F. Focus is the point on the principal axis. So distance between, this is the pole, distance between pole and focus, this is denoted by small f, that is focal length of the mirror, and the distance between C and P, it is a radius of curvature. So R is the radius of the sphere of which this mirror forms a part. So these are terms which we have discussed it earlier. So now we have to derive the relationship between this small f, focal length, and the radius of curvature. For that case, let's take the case of a concave mirror. Suppose this is the concave mirror. This concave mirror. Here we assume that this concave mirror is of very small aperture. So this is the principal axis of this mirror. This is the pole. Take this is pole. P is the pole. Here we consider that a ray of light. Suppose this is the AD ray of light. It is incident on this mirror at the point D. It is parallel to the principal axis. Since it is parallel to the principal axis, after reflection, it passes through the focus of the mirror. This is the point F. Passes through the focus of the mirror. This is the reflected ray. Here it was the center of curvature. So from center of curvature, the line between any line drawn from center of curvature to any point on the mirror is the normal. So this is the normal. This is the normal. CD is the normal at point D. If it is normal, the angle between the incident ray and the normal at the point of incidence, D is the point of incidence, that is called angle of incidence, and this is the angle of reflection, angle between this normal and the reflected ray, D E लिखेंगे reflected ray. This is the angle of reflection. As per the laws of reflection, I is equal to R. I is equal to R. So CD is normal. यहाँ हम लिखें CD is normal to mirror at D. So I is equal to R. I is equal to R. I, angle of incidence, is equal to angle of reference. Since as C is the center of curvature, DC जो है CD or DC, CD is the normal at point D. So as per the laws of reflection, this angle ADC, this angle I is equal to angle this angle R. What is angle R? CDF. Angle CDF. This is because angle I is equal to angle R. This is the laws of reflection. इसको हम first लिखेंगे equation first. Again, AD and CP, these are parallel lines, and CD is the transversal. So angle I is equal to this angle 1, angle ADC, I is ADC, is equal to angle 1. Angle 1 is the DCF or FCD. Angles, equation second. जब हम compare करेंगे ADC first and second, so ADC equal to ADC, it means that angle CDF comparing first and second, from first and second. So angle CDF is equal to angle 1 CDF. This CDF is equal to angle 1. So these two angles these two angles are the angles of the same triangle. So since in triangle a CDF, this is the triangle, two angles are equal, therefore by theorem side is opposite to equal angles, are also equal. So what is this side to this angle? 1, that is DF. FD एंगल आर का अपोजिट साइड कौन सा है? CF, दैट इज इक्वल टू CF. FD इज इक्वल टू CF. फर्दर हमने बोला, जो जूम किया है पहले, जो ये अपर्चर जो है ये मिरर है, इसका अपर्चर इट इज़ वेरी थिन, इट्स अपर्चर वेरी वेरी स्मॉल. सो इट मीन्स दैट जो AD हैं, AD एंड प्रिंसिपल एक्सिस, दे आर क्लोज टू ईच अदर. They are close to each other like this. They are close to each other. It means that F and D almost coincide. F and D almost coincide. These F and D, this D and P, they are almost they are very close to each other. It means that FD, जो FD हैं, FD and FP, they are all almost equal. Here FD is equal to FP. Approximately यहाँ अगर ऐसे लिखेंगे, FD is almost equal to FP. So this is equation third, this equation fourth. यहाँ हम कंपेयर करेंगे आपस में थर्ड एंड फोर्थ जब कंपेयर करेंगे, FD is equal to FD, CF is equal to FP. CF is equal to FE. ये हो गया CF is equal to. फर्दर जो अगर हम यूँ CP करेंगे, CP किसके बराबर है? ऑल्सो CP equal to CF plus F is the point on CP, CF plus FP. CF plus FP. यहाँ CF जो CF हैं FP के बराबर हैं, और CP is equal to CF के बाद देखें FP प्लस अपना जो ये FP है, FP और CP is equal to FP plus FP, that is 2 times FP. This is the relation. So यहाँ हम साइन कन्वेंशंस अप्लाई करेंगे. अप्लाइंग साइन conventions. CP, what is CP? CP is the distance between C and P, that is R. We know that is R. CP is equal to R, but as per sign conventions, we have to measure distance from the pole of the mirror like this, but rays starts from A to D in opposite direction. CP is equal to minus R. Further, FP is what is FP? Distance between focus and polar, that is focal length. Again, we have to measure the pole distance polar mirror. We have to start from polar mirror like this, and the ray of light is opposite to this distance. Again, F is equal to minus, FP is equal to minus. यही हम इस इक्वेशन 5 में यूज़ करेंगे. यूजिंग इक्वेशन 5, what we get? CP is equal to minus R, FP is equal to minus F, so 2 minus F, or minus R is equal to minus 2F, minus cancel, F R is equal to 2 times F. यहाँ ऐसे भी लिखेंगे हम, R is equal to F, F is equal to R by 2. This is the relation between R and F. यानी जो F है, F focal length, focus F, it lies at the center of C and P in the mirrors whose aperture. But you should remember, it is not always true. It is true for thin spherical mirrors, when the mirror which is under consideration is of very small aperture. And these small the mirrors with small aperture, they are called thin spherical mirrors. This relation is valid for thin spherical mirrors. F is equal to R by 2. This is the relation between F and R, and thanks.